See it right there, looks good. And now I'm going to develop my second relationship with block B. And with block B, first I draw my inclined plane, choose the positive x direction, and I have, it's inclined at 30 degrees. I have the weight of block B coming straight down, and I just extend my normal line to get my y-axis, and that's going to be 30 degrees off the y-axis. That's going to be y. And I have my normal, my friction, and my tension. My tension, if you'll recall, these two blocks are connected at a point here, so the tension is going to be going up. And I think that the block's going to be moving this way, since this block is going to be moving down. And so the friction is going to be against motion, so the friction is going to be positive x. Equals the mass of block B times the acceleration of block B. Acceleration of block B is going to be in the negative x direction. So I get WBX plus my friction minus my tension. So the weight in the x direction is going to be positive, the friction positive, the tension negative, equals negative mass of block B times the acceleration of block B, and again that's negative because it's going in the negative x direction. And so I plug in our numbers, I solve for friction, I solve for mass, and I solve for the weight in the x direction. The mass is just the weight divided by whatever the acceleration due to gravity is, and since this is working in pounds and feet, it's going to be 32.2. That's going to be whatever the weight is divided by 32.2. And our friction is going to be whatever the normal comes out to be times our coefficient of kinetic friction. And our WBX is going to be this, so it's going to be whatever the weight is times the sine of 30 degrees. And so now we have two equations. And we know that that the acceleration of A equals the acceleration of B due to our cable relations. And so knowing that, we can solve for the tension and the acceleration using two equations, equation 1 and equation 2. Equation 1 developed from block A, equation 2 developed from block B. And say we just plug in for T here, solve, we get T equals 30.38 pounds. The acceleration equals 2.07 feet per second squared, and just designate the direction that it's going with the 45-degree angle in the arrow. And B is 2.07 feet per second squared in this direction. And so now that we have our acceleration, we need to use rectilinear motion in order to solve for our velocity. And so in this case, we're working in the x direction. So the acceleration of A in the x direction is actually negative 2.07, because you'll see it's actually accelerating in the negative x direction. So over here, when we solve for RMP, we have to know that our acceleration is negative. And we have our initial position at 0, our initial velocity is 0, and then given in the problem is our final position is -1, and our final velocity is unknown. That is what we're looking for. So whenever I'm given a rectilinear motion problem and I see that I'm working with distances and velocities, and the acceleration is known, then right away I know that the type of problem I'm going to be solving is acceleration equals the velocity times the change in velocity over the change in x, and that's derived I derived that in a previous problem. If you'd like to check that out, it's derived in I believe the general work and energy formulation that I did earlier. And so knowing that the acceleration of A equals the velocity times the change in velocity over the change in position, I bring the dx over, and then I integrate. So I integrate in x. I integrate from initial position to final position, the acceleration, and for the other side, I integrate from, since I have dv, I integrate from the velocity, the original velocity, which is 0, to the final velocity. And so once I integrate, it's going to look something like this. I have a times x from 0 to -1, and I have v squared over 2 from 0 to vf. And I solve for vf, and it comes out that va in the x direction equals plus or minus 2.03. Again, it's plus or minus because you're going to have a square root in here. Whenever you have a square root, you should always put the plus or minus, because that's going to remind you what exactly am I talking about. And since I'm talking about it in the x direction, the velocity is going to be negative. It's not going to be positive, it's going to be negative. So depending on how I designate my direction, if I'm going to use plus and minus, it's going to be negative 2.03 feet per second in the x direction, in x. And the same is going to be true for our velocity in the b direction. And I think that that's about it. I will present 2 more versions of this problem just for more clarification on the relationship between Newton's second law, rectilinear motion, and work and energy. Thank you.